We finalized this week with the multiplication of two matrices. Now let's say I have matrix A is 1, 2, minus 1, 5, and matrix B is equal to 2, 1, 0, 2. Now, multiplying matrices isn't the same as multiplying the elements. That is not the way in mathematics you can multiply matrices. In data science, it would be called element-wise multiplication, but what we define as A times B in mathematics is something different. Now, there are many ways of writing this down, and I will show you my way, which is not necessarily the way. The book will probably show you a different way, but this helps me visualize it. So if I take A, I'll give myself a bit more space. 1, 2, minus 1, 5, and I have this imaginary set of lines here. And I take B is 2, 1, 0, 2. Now, A and B are both 2 by 2 matrices, and this is important because in a minute we'll show you that it isn't possible to multiply all matrices with each other. What we do, I'll get to this element first. This element can be found by taking the first element of row 1. So if we look at, well, we take the element of row 1, multiply it by element on column 1. So this is 1 times 2, and we add 2 times 0. So the second element of the first row multiplied by the second element of the first column. 2 times 0. So 1 times 2 is equal to 2 plus 0, and we end up with 2. The element here we can find by, and I'll take a different color, we take the, this will be the element on the first row, second column, so we take the first element on the first row, multiply that with the first element on here, so that's 1 times 1 plus 2 times 2. So that will be the second element of the first row and the second element on the first column. And we get 1 times 1 plus 2 times 2. So that is 1 plus 4 equals 5. Now next we have this element here. And I'll show you in a minute, but I know that the result of A times B will be a 2 times 2 matrix. So we had the element on the first row, first column, first row, second column, now second row, first column, and we basically do the same. I take this element, or the first element on this second row, multiplied by the first element on the first column, and we get minus 1 times 2 plus 5 times 0, and we end up with, well, minus 1 times 2, which is minus 2. And then to conclude, and I'll do that in black, we want the second row, second column, so we take the second row here, second column there, and we multiply the minus 1 with the 1, minus 1 times 1, plus 5 times 2, and that equals minus 1 plus 10 is equal to 9. So A times B is a square matrix, 2, 5, minus 2, 9. And I'll show you another example of this in a minute, but we do see that this row had 2 elements and this column had 2 elements. If this column would have had 3 elements, we wouldn't have been able to perform the multiplication. So if A is a matrix M by N, and B is a matrix R times P, we know that if we should be able to multiply these two must be equal to each other, and these are called the inner matrix dimensions. And in some programming languages, if you try to multiply two matrices and they don't have the same inner matrix dimension, you'll get an error saying mismatch in inner matrix dimension or something like that. So to be able to multiply them, these two must be equal to each other, and the outcome will be an M times P matrix. So was this the case for our first example? Well, these two are indeed equal to each other, and we were left with a 2 by 3 matrix. So an example of these dimensions is that if we take A is a 3 by 2 matrix and B is a 2 by 5 matrix, we see that the inner dimensions are indeed the same and the outer dimensions are 2 and 5. So if we multiply this, it will be a 3 by 5 matrix. So this is all fine, but what if we take A is a 3 by 4 matrix and B is a 2 by 5 matrix? Well, you can see that the inner dimensions here are not equal, and we cannot multiply these matrices with each other. Now, with the inner product and the cross product, we saw that they were commutative. Well, the inner product was commutative and the cross product was not. So is this the case? If we can multiply matrix A and B, is this operation commutative? Well, let's take an example. If we take A is equal to 2, 1, 1, 0, and we take B equal to 1, 2, which is a 2 by 1 matrix. Now, we know that A is 2 by 2 and B is 2 by 1. So A times B is a, well, these inner matrix dimensions agree, will be a 2 by 1 matrix. And I'll show you how that works. I'll use my, my trick here, is that we have 2, 1, 1, 0, and we have 1, 2. Then I multiply these two plus these two, so 2 times 1 plus 1 times 2 is 2 plus 2 equals 4. 1 times 1 plus 0 times 2 is 1 plus 0 equals 1. So A times B is equal to 4, 1. And it exists indeed. But now if we look at B times A, well, B is a 2 by 1 matrix and 1 is a 2 by 2 matrix, and this isn't even possible. So not for all matrices can we say that if we reverse the order of multiplication, it works. Now, okay, so this is a problem with dimensions. Let me just move this chair out of the way. What if we have two by 2 matrices, and I will take special matrices 1, 2, 3, 4, which is not particularly special, but B, and let's see, can we still see this? Yes, we can still see this, is 0, what do we take? 0, 0, 0, 1. Now, A is 2 by 2 and B is 2 by 2, so I can multiply A times B, and I can also multiply B times A. So in theory, you'd think, well, okay, these multiplications are possible, but are they also the same? Well, if I multiply A and B, and I'll just do that, but I'll need a bit of space. Yeah. All right. So I have 1, 2, 3, 4, and 0, 0, 0, 1. For the element on row 1, column 1, 1 times 0 plus 2 times 0 is 0. First row, second column, 1 times 0, 2 times 1 is 2. And 3, so second row, first column, so we take the second row and the first column, well, 3 times 0, 4 times 0, it's both equal to 0. 3 times 0 and 4 times 1 is 4, so A times B is equal to 0, 2, 0, 4. Now let's see what happens if we reverse the 2. So I have 0, 0, 0, 1, 1, 2, 3, 4. Now, 0 times 1 plus 0 times 3 is 0. 0 times 2 plus 0 times 4 is 0. 0 times 1 plus 1 times 3 is 3. 0 times 2 plus 1 times 4 is 4. So B times A is equal to 0, 0, 3, 4. So in general, unless they have very, very special properties, A times B will definitely not be equal, in general, to B times A. There are matrices for which this does work. But in general, you cannot assume that multiplication of matrices is commutative. So this is all I have on multiplying matrices, and these are all the operations we'll do for now on matrices. And from here you can start with the questions for week 2.